Welcome to this presentation of our paper, Getting Started with Low Code, a data-centric primer for Oracle APEX, authored by Professor Reciceka, Professor Kapsamer, Professor Pröll, and myself, Wieland Schwinger, from the Johannes Kepler University Linz. The work presented is part of our project Better Employability with APEX, funded by the European Union under Erasmus+. Due to the tremendous growth of the IT sector, the demand for personnel being able to develop web applications is massively increasing. Not least to cope with these needs, low-code platforms have emerged, aiming to reduce repetitive programming and enhance productivity, being increasingly attractive to many non-IT experts, thus empowering emerging so-called citizen developers. Those low-code platforms, however, often come overloaded with a lot of features which actually might hamper their adoption. Consequently, to lower the barriers for citizen developers, we try to cut the path through the low-code feature jungle by providing a primer for non-IT experts with the example of Oracle APEX, thereby determining the typical development process characteristics and specifically exploring reuse potential. For our investigations, we've resorted to Oracle APEX as an example for a low-code development platform, as it is based on the widely used Oracle database management system and as it supports a wide spectrum of application domains. Web applications developed with APEX have a data layer-driven web layer. APEX supports a cyclic and incremental low-code development process based on web browser-based tools and wizards to build complete web applications. The database layer of such a web application comprises the database schema and the data needed for the application. It can be developed either from scratch or in a reuse-driven way, allowing for offline input-export as well as online data exchange. The web layer builds upon the database layer. APEX supports the specification of web pages and the creation of the web application as well as their execution. The web layer can again be developed from scratch by reusing existing parts of web applications. In case of APEX, web applications, the generated artifacts themselves are stored within the data layer. As the web layer is based on the database layer, let's have a look at it first. For developing the database layer, the first step needs to deal with creating the database schema in terms of the database tables. Based on that, in a second step, we can turn to storing and manipulating the required data, as well as querying the data. Thereby, data exchange forms a cross-cutting concern for providing offline import and export of data, as well as online data access for other applications. Turning to the first step, the creation of the database schema. This can be achieved through reuse, or the schema can be specified from scratch. In any case, you finally need the actual data definition statements, meaning the create table statements for the actual creation of those tables in the database. In case such data definitions are available in form of DDL scripts, we can simply import and execute those scripts. In case data exists, e.g. in external spreadsheet files, APEX supports automatic schema inference that can be augmented by the user via a wizard. However, this option is limited to simple tables only. In case we need to develop the database layer from scratch, there are different options available. Starting with the option being most distant from code and thus providing the highest level of abstraction for non-IT experts with model-driven schema creation. This is, however, not supported by APEX itself, but through other tools like the Oracle SQL Developer Data Modeler. A logical model, very often in the form of entity relationship diagrams, allows to focus on simple concepts, entities, attributes, and relationships, and thus doesn't need to consider database system specifics. Database system-specific models, in case of APEX being based on the relational database schema, the relational model can be generated automatically, but more database-specific details like data types and foreign keys need to be manually added before the actual DLL script can be generated. That script can then be imported into APEX and executed to generate the database tables. As a second option for users with no modeling experience, APEX offers a wizard for low-code development of individual tables only. Alternatively, as a third option, a non-standard notation coined QuickSQL is available that allows to specify the schema. It offers limited expressiveness, but is particularly beneficial for quick testing, not least since it allows to insert random test data. Finally, APEX allows for SQL command-driven creation of the schema, requiring resorting to do SQL DDL statements. While such create table statements allow to specify every detail and is not dependent on any generation process, the entailed burden is to deal with code and concrete syntax. Having specified the schema, we can now turn to the data and how to provide data offline through import and export or through online data access through external clients. A wizard-driven import is provided for both data from files, whereby comma-stated value lists and XML are supported as file formats, and data in existing tables. In the course of that, the data source as well as the target for import in terms of either mapping to an existing table or the creation of a new table needs to be selected. For exporting data, again, a wizard is provided supporting a necessary step for selecting the table and columns. As export file formats, Excel lists or JSON is supported. The specification of online data exchange is supported in a low-code way by the auto-REST feature of APEX. REST enables access to data in terms of HTTP requests equivalent to the standard CRUD operations found in databases. The simple two-step process for generating the REST feature is, however, limited to a full table scan and JSON's output format only. Summarizing, the database schema can be generated in a reuse-driven way if DDL scripts or data exists. From scratch, there are several different options available in APEX, from abstract model-driven specification over wizards to low-code proprietary languages to plain DDL code. Data exchange is supported by APEX for offline import and export of data, as well as online access through a REST interface. Having investigated the low-code development process for the database layer, let's turn to the web layer built thereupon. The low-code development process for the web layer in APEX forms a four-step process, which starts depending on the reuse by reusing existing web application, tables, or data. At the core of the web application development is the specification of necessary additional pages on top of existing database tables. Upon that, web applications can be automatically generated and run. The overall process is thereby a multi-step, partially cyclic process allowing for incremental development and thus a stepwise refinement of the web application. During the first step, if data exists in external files, the database layer, as already mentioned, can be automatically generated, serving the next steps in the process. If the database layer or parts of it already exists, then the web layer can be automatically generated thereupon. Maximum reuse can be achieved if a web application already exists to base upon. In the next step, making up the core of the web application layer, pages can be incrementally added to the web application, being based on database tables for visualizing and manipulating data. APEX thereby hides the programmatic layer in terms of low-code development through wizards, allowing to generate different types of pages with predefined functionalities for data retrieval and manipulation. These pages can later be maintained and enhanced, as well as interlinked. During modification of pages supported through a set of forms and wizards, also extension points are given to add code. During development, the web application needs to be generated once in the course, of which overall properties and additional functionality can be specified before the necessary web artifacts are created and stored in the database layer. The web application can be altered, pages modified, and new pages added at any time later, supporting incremental development. Having the web application generated, the resulting web application or individual pages can be rendered to see the resulting behavior. Thereby, the developer can directly navigate back to the page designer to change the specification of a particular page. This allows for interactive testing and facilitates incremental development of the web application in a low-code fashion. In the work presented here, in the first step, we intended to shed light on the different options for developing the database and the web layer, and thus cut the path through the low-code feature jungle by providing a primer to Oracle APEX as an example for a low-code development platform. taking up a non-IT perspective, pointing out typical development process characteristics, and exploring reuse potentials. To further lower the barriers for non-IT experts to get engaged in local development of web applications, in the course of our BeeAPEX project, we are currently working on 12 highly practice-oriented business use cases ranging from simple web shop, a course scheduling system, car rental case, to a diet management app, to name just a few. For these use cases, detailed use case descriptions comprising a business view, problem definition, use case diagrams, and data models, along with a step-by-step realization guide, will be provided. This, together with other efforts of our BeeAPEX project, intend to empower non-IT experts to become knowledgeable citizen developers and thus ultimately to improve their employability in the labor market. Thank you very much for your kind patience and attention.